So what is radiation? Radiation is one of the mode of heat transfer. So we need to look at four main points to understand the basic things regarding radiation. The first is again the medium. The second is the motion. The third is the formula or equation. And last is the physics. Okay. So for medium, we may note that radiation doesn't require any medium to occur. Require any medium. If medium is present, radiation can occur. If there is no medium, if there is vacuum, in that also radiation can occur. So that is a special feature of radiation. The convection and conduction cannot occur without any medium. It requires a medium for heat transfer. Radiation doesn't require any heat transfer. Through rays, we are going to transport energy from one location to another. Motion, so it says nothing about motion. The body can be in motion, it cannot be in motion, it can be stationary. It is irrespective of that. So the only condition, so instead of this, we'll understand the thing condition. So for the only condition for radiation to occur is the body should have a temperature, absolute temperature greater than 0. What does an absolute temperature mean? So let me clarify it. So the absolute temperature it's nothing special, but it's a technical term, that's why I am highlighting on it. The absolute temperature means the temperature in Kelvin. That means there is no negative temperature possible for absolute temperature. The absolute temperature ranges from 0 to infinity. But if we write in degrees Celsius, it ranges from minus 273.15 degrees Celsius to infinity. So this negative is possible if we use the unit as degrees Celsius, but for the unit as Kelvin, there is no negative. That's the meaning of absolute temperature. So the only condition is that the body should have a temperature greater than 0. That is always possible. It can occur in all medium, by all matters, in all medium, doesn't matter. And let's look at the equation now. So it is defined by Stefan Boltzmann law. Defined by Stefan Boltzmann law, and that involves sigma, that is Stefan Boltzmann constant. So my energy of black body, energy like maximum emission power of a black body is EB, given by sigma Ts raised to 4. This Ts must be the absolute temperature. Sigma is Stefan Boltzmann constant. EB is emissive power. So that is maximum emissive power. So the maximum emissive power is always of a black body. That is by law. Black body is defined by having an emissivity of 1. So we'll also include that emissivity for real bodies. So for real bodies, this emissive power EB, this E is the real body emissive power, that is some factor sigma times EB. So obviously we know that the emissive power of real bodies is less than EB, that is maximum emissive power, that is the emissive power of a black body. That means my value of epsilon is less than 1, greater than 0. And this epsilon which I am using is a radiative property, and we call it as emissivity. almost I have defined everything. Now there are a lot more things with respect to this formula. So we have absorbivity, reflectivity, everything. So we'll cover that in another video. As of now, we'll go to physics. So in physics, it's very simple. The whatever energy is transferring, that energy is inside the electrons. So in an atom, we have the electrons. So these electrons have energy. So whatever, if they have higher energy with related to their state, so they can only have that quantum of energy. So if they have higher energy levels, they'll emit energy in terms of rays or radiations. And as and when they emit radiations, there is a change in the electronic configuration. As the radiations are emitted, there will be a change in the electronic configuration of the atoms. That's how the atom will lose energy. That's how the material will lose energy. So any radiation which is emitted by surface is the thermal energy bounded by the surface. Whatever body we have, the energy is bounded by the surface, and that whatever radiations we are emitting, they are emitting from the surface. So that's the basics of radiation. In next topic will be more regarding the details of emissivity, absorbivity, reflectivity, etc. And we'll also go on absorption power and irradiation. So this was radiation. Irradiation is also a complementary topic, so we'll look at that. Thank you.